Please allow me to share my material. All right, I'm going to share my link very soon. Now, the topic we want to solve tonight, like I explained, okay, like I explained in our last class, that is, okay, I'm now the host, I can share now. All right, let's go to it. All right, let's go to it, please. Now, the topic we are looking at, in the last class we had during the salad break on Wednesday precisely, I explained that this topic may be coming to some of us for the first time, particularly if you are taking SFM for the first time. Now, like all new topic, there's going to come with new knowledge. To acquire new knowledge, it takes patience, perseverance, and persistence. This topic is a topic that might be coming to us because we don't have option markets well pronounced in Nigerian financial markets. At that class, at that lecture, we define option as the right, but not the obligation to buy or sell an underlying asset at a predetermined price known as the exercise price within a specified future period or on a particular future date. Let us explain that definition. Option is the right to buy or sell. That right to buy is known as the call option, while the right to sell is known as the put option. The underlying assets can be financial assets, like your stock, like bond, like foreign currencies. The predetermined price is the exercise price. You can obtain a right today to buy an asset at a future period. You can obtain a right today to buy an asset at a future specified period at a price agreed today. But remember, it's an option to buy, not an obligation. On the other hand, you can obtain a right today to sell an asset at a future period. The right to sell is put option. Now, for you to obtain this right, for you to obtain the right to buy or the right to sell, you must pay a premium. You must pay a premium for this right. The premium to be paid must be paid immediately. So if you want to obtain a right to buy an asset at a price agreed today, you are going to pay a premium for that right. The premium you paid for call, for a right to buy asset, is what we call call premium, or call value, or call price. If you want to obtain a right to sell an asset, if you want to obtain a right to sell an asset, you must pay a premium for that right. The premium you pay is called the put premium, or the put price, or the put value. Now the question is, how do we determine the premium we pay? How can we compute premium? To calculate premium, there are different models that can be used to calculate premium. However, ICANN has selected Black-Scholes option pricing model. You can use Black-Scholes. We have the binomial model, but currently, ICANN has been examining Black-Scholes option pricing model. The Black-Scholes model can be used to determine the fair price. Look at it, please. The Black-Scholes model can be used to determine the fair price or the theoretical price. Somebody is chatting. You should check his mails. Or you can use the previous link. I was looking for, please, just 1 minute. I was looking for the link too. Let me respond to Abu. Please. Use. Sorry, I'm trying to respond to that student. The link, I'm not sure the link was shared today, but it's the same link. So I was also looking for the link to take the class. So sorry, I'm trying to respond to that student so I can be part of the class. Now, the Black-Scholes option pricing model is a mathematical model that can be used to determine the fair price or the theoretical value of a call or a put option based on 5 variables. What are these variables? 1, underlying asset price. That is the underlying stock price. 2, exercise price. 3, time to maturity. 4, the risk-free rate. And 5, volatility. Please, at any point in time you want to determine the value of a call or the value of a put, these 5 variables must be in place. Number 1, the underlying asset price. Number 2, the exercise price. Number 3, the time to maturity. Number 4, the risk-free rate. And number 5, the volatility. These 5 variables are required to value option. We now stated the formula. Please, I try to encourage students. This topic is just a one-way method. There's no way examiner can twist question, but you need to just try to understand it. To calculate your core value, look at the formula, please. As highlighted, this formula will be given at the back of your examination script. To calculate put value, look at it, please. Then you have your D1 and D2. We'll try as much as possible to demonstrate this in the classroom. We can use it to determine the value of the core or put options. We explain this. Then we explain the Greeks. We said Greeks measure the sensitivity of option value to a change in any of the input variables. The Greeks measures the sensitivity of option value to change in any of the input variables. What are these input variables? Underlying asset price, the exercise price, risk-free rates, time to maturity, and volatility. We now explain type of Greeks. Data measures the relationship between change in option price as a result of change in asset price. Please remember, the asset could be stock, the asset could be shares, the asset could be bond, the asset could be foreign currencies. We refer to it as financially traded assets. With Black School, data can be approximated as, please note, data of a call, ND1, data of a put, ND1 minus 1, data of an asset 1. I'm trying to do a recap of that class. And I explained that you can also use data as an hedging tool. A data neutral position is one whose value does not change. In response to changes in the value of the underlying assets. When we say hedging, if you place your investment in a company, let's assume you have investment with First Bank. We are all aware that share price fluctuates regularly. That means your investment value can change regularly. How do you protect that investment against fluctuation in value? You can data hedge. You can hedge that your investment using data. The objective of a data neutral portfolio is to combine a position in assets with a position in option. So that the value of the portfolio does not change. For the value of the portfolio not to change, total data must equal to 0. God willing, we demonstrate this tonight also. We explain gamma. Gamma measures the amount by which data value changes as the price of the underlying assets changes. As share price is changing, what is the change in data value? That is what gamma measures. As currency price changes, what is the change in data value? We have theta. Theta measures the change in option price brought about by change in time to maturity. It's for you. Change in option value as a result of change in time to maturity. We talk about RHO or RHO. RHO. RHO measures the sensitivity of option price to change in risk-free rates, interest rates. RHO is positive for call option and negative for put option. Lastly, we explain Vega. Vega measures the change in option price for a given change in volatility of the underlying assets. If there's change in volatility, your volatility is risk, standard deviation. When we say volatility, I've defined it before. Risk is defined as the volatility in expected return. If your return is not stable, that means there is high risk in that business. If your return, if the return from your investment fluctuates frequently, that means that investment is highly risky. Now, what is Vega? Vega measures change in option value for a given change in volatility of the underlying assets. Vega is positive for both call and put options. This is the summary of the explanation we had on Wednesday last week. Today we are going to put question to it. I encourage us all. Do not be discouraged. Please ask question when you are in doubt. We are looking at question number 1. Question 1. The management team of Grand Square PSC are currently reviewing the company's investment portfolio. About 15% of the portfolio is represented by a holding of 5,550,000 ordinary shares of Niger Dockyard PSC. Let's explain that sentence. Grand Square PSC has investments in another company called Niger Dockyard PSC. They have 5,500,000 ordinary shares of Niger PSC. The managers are concerned about the effects on portfolio value if the price of Niger Dockyard shares should fall. Look at it. Our company, Grand Square, we have investments in Niger Dockyard. Our managers are worried that should the share price of Niger Dockyard fall, what will be the impact on our portfolio value? And are considering selling the shares. Our managers are looking at selling these shares. If you look at that clearly, if the share price is rising, we can sell at higher price and make more money. But our fear is if the share price should fall, then that will reduce our investment value. Grand Square Management, Grand Square Investment Board has suggested that the risk of Niger Dockyard shares falling by more than 5% from their current value could be protected against by buying an over-the-counter options. Look at this. We can protect our investments against fall in share price by more than what? 5%. That means if you look at that sentence, the company can tolerate 5% fall in shares, but anything more than 5% fall in share price, we want to protect ourselves by buying over-the-counter option, over-the-counter options. We want to protect our investment against falling price. Hence, we now want to buy option. An investment bank is prepared to sell an appropriate 6-month option to Grand Square for $250,000. A bank has offered to sell to us an option to Grand Square for $250,000. That means the investment bank wants us to pay $250,000 premium as option. Option premium. Once we pay this premium, the investment bank will now give us a right to sell our shares. In 6 months' time. Once you obtain the rights now, we are going to say, okay, we can tolerate 5% fall. That means 5% fall in price is tolerable. We now determine 5% fall. We'll come to it. Other information. The current market price of Niger Dockyard ordinary share is 360 kobo. The annual volatility in bracket variance of Niger Dockyard PSC shares for the last year was 196%. Please note, volatility must be represented by standard deviation. In this question, the examiner says volatility is in brackets. Is equal to variance. That means we need to move a step. I need to compute variance. I need to compute standard deviation. And remember, standard deviation is the square root of variance. The risk-free rate is 4%. No dividend is expected to be paid by Niger Dockyard. Requirements A. The examiner says evaluates whether or not the price at which the investment bank is willing to sell the option is a fair price. Now you now ask yourself, what type of what are we trying to evaluate? Merchant bank has said we should come and pay a premium of $250,000. The question now says evaluate if that premium merchant bank said we should come and pay is a fair price. That's okay. How can I determine the fair price of option? I can make use of Black-Scholes model. Look at the definition, Black-Scholes option pricing model. The Black-Scholes option pricing model is a mathematical model for calculating the fair price or the theoretical value of a call or put options. That means for me to determine the appropriate price or the fair price, I can use Black-Scholes option pricing model. Now, the second question is, in this question, are we dealing with call option or put option? How will I know? Look at the body of the question. Our company, we have 5,550,000 shares. The managers are concerned about the effect on portfolio value of the price of Niger Dockyard shares should fall. And we are considering selling the shares. Please, what is the right, if you want to sell your shares, what is the right to sell? The question is to the class. What is the right to sell? Please, let's try to participate in this class. Please, let's try to participate. I try to explain it. What is the right to sell? Yes, we are not responding. What is the right to sell? The right to sell is put option. I'm trying to also explain this at the start of class. We said option is the right to buy or sell. The right to sell is put option. That means the appropriate contract this company needs to buy is put option. The company needs to obtain a right to sell the shares at a price agreed today. That means we need to determine put premium. We need to determine what the put premium. There are two ways to calculate this. You can calculate core value first. When you get the core value, you now go and calculate, you now use the core value to calculate put value. This question is about right to sell. The investment bank is prepared to sell an appropriate 6-month option to Grand Square. This will represent a put option to Grand Square. To determine whether or not the price at which the merchant bank is willing to sell the option is fair will depend on the value of the put option compared to the asking price. We can first calculate value of call option. Then the value of put option can be calculated using the put call parity theory. Okay. Now, we want to calculate value of put option. In this solution we have provided, we took an approach from call option to put option. Now, I'm going to now solve using the put option value directly. I will now solve using the put option value directly. You can now compare the two solutions. Now let's go to the whiteboard. Please, encourage us. Let us try to participate. If you are in doubt, you can ask questions. Don't let us go with the impression that, okay, like students will usually say, if it's an option, there will be an option in the exam. So, and that will make students to close their mind to what is being taught. All right, please, let's encourage ourselves. Please encourage me also by trying to participate. Wait, so where's Zainab? Zainab is not online. Oh, I hope she's not tired, because it's less than a month to exam. Please don't let us get tired, or let us encourage ourselves. Even we lecturers, we are tired since January. Now, the first thing you do, you want to determine put value. Put value. State your formula out. Look at the formula. The formula is capital letter E, exponential letter minus R T multiplied by N minus D2, close your brackets, minus, open another bracket, XO multiplied by N into bracket minus D1. Please don't be disturbed by the noise of the question or by the noise of the formula. Then define your variables, your XO. It is the current stock price. Look at the question. What is the current stock price?
360 kobo.
Thank you. 360 kobo. 360 kobo. Your capital letter E is the exercise price. What is the exercise price? The question says the company can tolerate 5% reduction in share price. The company can protect itself. Let's go to it. I want to try and see how much I can carry you guys along, but you must be willing to go along also. Look at it, please. Grand Square Investment Board has suggested that from their current value can be protected. That means we can tolerate 5%, but more than 5% is not tolerable. So to get your exercise price, 5%, deduct 5% from 360. Compute 5% and deduct from 360. That becomes your exercise price. What do you have, please?
342.
Thank you. So please, if you are looking at the working, You have 360 multiplied by, open your bracket, 1 minus 0.05. If you work this out, it will give you 342 kobo. It's your time to maturity. How many months are we looking at? 6 months. It's in the question. 6 months. This is not up to 1 year. You have to prorate it. 12 months make 1 year. This becomes 6/12. That means your time to maturity is 0.5. You can also copy. Some students will actually copy it. That will make you not to sleep in class. Your small letter R, that is the risk-free rate. Look at the question. What is the risk-free rate? 4%. That is equal to 0.04. Let us share the question and show it again. Look at it. The risk-free rate is 4%. Annual volatility variance 169%. I'll come here. Our volatility is must equal to standard deviation. And I'm giving variance. Remember, standard deviation is the square root of variance. That means my volatility is going to be, if I want to get volatility, is equal to square root of 169. That will give me how much, please? 13%. That is equal to 0.13. You have gotten the 5 variables. The next thing for you to do is your D1. Let me put a small demarcation here. It's not a crime if you copy. Let me continue with the red. I'm trying to change it to black now. Oh, see this thing, let me move now. Bring it here now. Now, your D1. What is the formula for D1? It's also in the question. It's also in your D1 is equal to in brackets XO all over capital letter E. Close your brackets plus open a bracket, another bracket, small letter R plus 0.5 is constant with that formula. Then volatility square. Close your bracket plus T all over volatility square root of t. Please, do not get carried away by the noise of the formula. What is important is application. No, white again. I can come here now. My D1 is equal to in. In is on your calculator. Open a bracket. Your XO 360 divided by 342. Close this bracket. Plus, open another bracket. Your small letter R 0.04 plus 0.5 multiply by volatility 0.13 raised to power 2. Close this bracket. Multiply by T. .5 is here. 0.5 all over volatility 0.13 multiplied by square root of 0.5. Let us go to our calculator. Please, if you are genuinely interested in learning this, let us get our calculator. I'm going to enable my video temporarily. Pick your calculator. Please pick your calculator. Look at my calculator. Please let us work together. All right. On your calculator, you have in. Press in. For some calculator, it comes with brackets. Immediately you press your in, that in is called natural log. For some calculator, it comes with brackets. For some, you need to introduce brackets yourself. Now, depending on your calculator, please open a bracket. 360 divided by 342. Close the bracket. 360, you press in, open a bracket, 360 divided by 342, close the bracket, then plus, open another bracket, 0.04 plus 0.5 multiplied by 0.13 raised to power 2, then close the bracket, multiply by 0.5. Please obtain your answer. Please obtain your answer. You should have, what do you have, please? You should have 0. Can we respond by a chat? 0.0755. 1829, 439. For the numerator, you should have 0.05755 1829. Please confirm you have this figure. Please confirm, can we confirm you have this figure? All right, thank you, Debbie. If you have gotten that figure, now, introduce divided by. Once you have done that, now you have two figures down. That two figures you have down to divide, you need to put introduce bracket. Bracket 0.13 multiplied by square root of 0.5. Open a bracket, 0.13 multiplied by square root of 0.5. Now obtain your answer. Your D1 should give you I'm trying to get the cursor out. Your D1 should give you 0.8215, 4 decimal places. Your D1 should give you 0.8215. Please, can we confirm we have this figure? Please, can we confirm we have this figure? Let's try to manage time. We are trying to get ourselves along. Thank you, Debbie. You have gotten the D1. Please, in line with ICANN standard, you must maintain 4 decimal places. Your D2, the formula for your D2 is D1 minus volatility square root of T. You may want to ask, why are we calculating D1 and D2? Look at it. I require D1 here. I require D2 here. That means without calculating my D1 and D2, I cannot value options. Is that clear, please? I require D1 here. You might try to ask, I don't even know why the lecturer is calculating all these D1 and D2. It is the formula that we are using. There's D1 here. There's D2 here. Then I need to get these two out. So we now proceed. Your D2 all right, blessing, fine. Although I must confess, Blessing and Debbie, I've not been seeing you guys in my class, so I know Amaka, I know Abu, I know Fidelis, I know. I've not been seeing two of you in my class, I don't know.
I've always been in your class, so I've not missed any of your classes.
Okay, My apology there. Maybe I didn't notice. Now let's continue. I can now get my D2. My D2 is equal to 0, that space take me, 0.8215 minus, open a bracket, 0.13 multiplied by root of 0.5, root of 0.5. Now let's try to work this out. Now pick your calculator again. To get your D2, 0.8215 minus, open a bracket, 0.13 multiplied by the root of 0.5. What's your final answer? 4 decimal places. Your D2, let me pick in red. I want to manage here. Your D2 should give you 0.72 96.7692. Let me link this to this. In case you are copying it, you know how to copy appropriately. At the same time, let us also find a way to link this together. I can link these two together. All right, great. You have gotten D1 and D2. Like I explained, based on ICANN standard, for your D1 and D2, you must maintain 4 decimal places. Based on ICANN standard, for your D1 and D2, you must maintain 4 decimal places. Any questions so far? Any questions so far? Even if you solve only one question and you understand it very well, it's better than solving 2 questions that you don't understand. Any questions so far?
Yes, I have a question.
Okay, great. Amaka.
Yes. No, it's blessing, sir. Blessing.
Oh, forgive me. Oh.
No problem, sir. My question is concerning, we were able to bring out all our
Variables.
all our variables, yes. But what makes up that small e?
Okay. That small e is exponential function. It's on your calculator also.
Okay, sir.
All right. That's a good one, that we define everything, but we didn't define small e. That small letter e is exponential function. Where you have in, if you check the up of where you have your in, you are going to see that exponential function, small letter e.
Yes, I've seen it now. Thank you.
All right, that's a good one. That's a good one. All right. Now, please note our D1, our D2. We open a new whiteboard to continue the class. You can save this. Here's a question on option. Option, working one. Just 1 minute. Let me take water. Now, continue. Once you have gotten your D1 and D2, the next thing is the next thing you are going to do. Your next working. Your working two, if you are following working two, your working two is to determine N D1 and N D2 using distribution, normal distribution table. This N stands for normal distribution. This is normal distribution 1, normal distribution 2. That was the table I was saying we should try and get. If you have the table, we can work with it. Although the table is also available in the question. That means I have to move to the question. You start first with D1. You start with D1. Our D1 figure is 0.8215. Now, before you move to your D1, ND1, you are going to determine a range. This number will be on a range on the normal distribution table. It's a range. If you look at this number, assuming I draw a line graph, look at it, please. Assuming I have a line graph like this, I'm trying to explain. I have 0.80 here, 0.81, 0.82, 0.83. Please, where will this number lie? 0.8215. Where would this number lie on my graph, on my line graph? This number will lie between here, somewhere here. That means it's between these two figures. Is that not, please? If you look at it, this number 0.8215 is between 0.82 and 0.83. That means this number range between, the range is between 0.82 to 0.83. You must determine the range. Like I explained in the physical class, they were like, what kind of thing is this? By the time you solve one question, two questions, you are going to get used to it. Once you establish your range, you now come to your ND1 is equal to now, normal distribution table comes with 0.5 plus or 0.5 minus. Normal distribution table comes with 0.5 plus or 0.5 minus. Now the question is, when am I going to use 0.5 plus? When am I going to use 0.5 minus? If your D1 or your D2 is a positive sign, look at it. Now I have my, look at this. Our D1 is positive 0.8215. Then if I'm going to end D1, I will start with 0.5 plus. But if the sign here happens to be minus, as mean you have minus 0.8215. Then if you get to your ND1, you are going to start with 0.5 minus. Let me take this one off. I hope that point is well taken. Please, like I said, feel free to ask questions. I'm aware that this topic is coming to some of us for the first time. Or some of us are even, we have done the exam before. We don't even have this knowledge. Then now open a bracket after your plus. Open a bracket. Now, if you have the log, go to the log. Check 0.8 under 2. If you don't have, let us go to the log together in the classroom. Now this, look at the log. This will be given to you on the exam days. I want to try to, if I can expand this more. Can I expand this more? No, you didn't allow me to expand. Okay, I think I've done small. Let's see. Now, please look at it. Look at my cursor. Look at it here. This is how you check. Look at 0.8. My 0.8. I will now go. I want to look under 2. Look at under 2 here. 0.2939. 0.8 under 2 will give me points. Look at under 2, under point, under 2, we call it 2. Don't bother about this 0.02, just pick under 2. That will give you 0.2939. All right, I will move back to the whiteboard. That will give us 0.2939. Then now add plus again. We have checked 0.8 under 2. That gave us 0.2939. I'm left with what, please? I'm left with these two figures. Is that not, please? I'm left with 1.5. Bring the 1.5 here. That becomes 0.15. I'm left with 1.5. I only put circle to explain it. Whatever you are left with, please don't do 0.0015. Just pick 0.15. I've only put this circle to explain the figure we are picking out. So let me remove that circle. I'll go back now. Now, when you are done with this, open another small bracket. You have checked the lower band, 0.82, because this number is between these two. Now go and check 0.8 under 3. We go back to that log again. 0.8 under 3. That will give me 0.2967. 0.2967. I will now come here. 0.2967. This is the upper band. When you get this, now say minus what you got in the lower band, 0.2939 minus 0.2939. This will give you your ND1 figure. This is how to use normal distribution table for this purpose. You can now do your calculation. 0.5 plus bracket 0.2939 plus 0.15, open a bracket, 0.2967 minus 0.2939. What is your final answer? Please let us participate. If you work this out, you are going to get 0.7943, if I'm not mistaken. Please apply your calculator and check. If I'm not mistaken, that should give you, let me check here again. Yeah, please do your plus minus. Confirm you have 0. All right, thank you, Blessing. You have gotten normal distribution log of D1. You have gotten normal distribution log of D1. You can now move to D2. You can now move to your D2. You can move to our D2. Our D2. Please, if there's any question, ask. We are available for your question. 0. If our D2, we calculated 0.7296. Our calculation in working one, we calculated 0.7296. Again, you are going to establish a range for this number. The range will be 0.72, 0.73. This number, 0.7296, is in between these two range. This number is in between these two range. You can now come here. Your ND2. Please, if there's question, call my attention. If I solve this one question and you understand it, it's better for me than rushing to question you don't understand. Like I said, normal distribution log comes with 0.5 plus or 0.5 minus. At what point am I going to use 0.5 plus? Look at the sign here. The sign here is my D2 is plus 0.7296. This is a positive sign. I will now come here. 0.5 plus. I will now open a bracket. Go and check 0.7 under 2. Let's check that log. If you have the log with you, please check. If you don't have, please, let's follow the class. Look at it, please. 0.7 under 2. The figure is 0.2646. I'll come here. That will give me 0.2646. Is that correct? Let me check again.
I think it's 4.2.
0.2642. Sorry. It's 4.2. This is 4.2. Then introduce plus. Now look at it. You have checked 0.72. You are left with what, please? 96. I'm left with 9 and 6. Now pick it. 0.96. Open another bracket. Now go check 0.7 under 3. 0.7. I will now trace it to 3. That will give me 0.2673. 0.2673. Then minus what you get in the lower band. Minus 0.2642. Please, what is your ND2? Normal distribution log of E2. Let me check quickly so that I can manage time also. Please still compute. The figure we got here was 0.27.7672. You should have 0.7672. You should have 0.77672. All right, thank you. You have gotten ND1 and ND2. All right, we can save this. We can save this. So that we can open a fresh working note. Option working 2. So our D1 we got, our ND1 we got 0.9, 0.7943, 0.7672. We open a fresh one. Let me expand this more. I can accommodate more. Okay. I've expanded this a bit. Now, you want to calculate value of put. I will bring the formula again. For value of put, I'll bring the formula again. Never mind. Formula is XO. No, is that correct? That's not correct. That's not the formula. It's put I'm trying to calculate. Okay. Capital letter E, small letter E, minus R, capital letter T. This is raised to power minus R T multiplied by N minus D2. Close your brackets, minus, open another bracket, XO multiplied by N minus D1. Now we have calculated our D1. Our D1 gave us 0.7943. But I hear N1. I can now compute N minus D1. This is equal to 1 minus ND1. This will give me 1 minus 0.7943. Please, what do you have? I've gotten ND2. It gave me 0.7672. I need to get N minus D2. This is equal to 1 minus ND2. This is equal to 1 minus 0.7672. Please, it is the formula that is informing this next calculation. If you look at the formula of call, you don't have N minus D1 or D2. So please, what is your N minus D1? That should give you 0. What, please? 0. That should give you 0.2075. Next, N minus D2. 1 minus 0.7672. Zero 0.2328. You can value your put option now. Remember that our XO is equal to 360. Our capital letter E is equal to 342. I can now say put value. Put value is equal to, look at the formula, open a bracket, capital letter E, 342 exponential minus My small letter r, risk-free, 0.04. Our R is 0.04. Our T is equal to 0.5. Multiply by 0.5. Because I have two figure up, I need to put brackets. Then multiply by n minus d2. 0.3, no, 0.2328. Close this bracket. Minus, open another bracket. XO 360 multiply by n minus d1 0.25, sorry, 0.2057. You can now get your put value. Now, please, let us walk through it together. Get your calculator. Let us walk through it together. Get your calculator. Get your calculator. Are we good to go, please? Now, you start with 342. My 342. Then the exponential sign. To get that sign, do shift, then press in. It will bring the exponential sign out. After you have typed 342, then press shift on your calculator, then press in. It's going to bring the exponential function out. Then now, when you have gotten the function, open a bracket. Minus 0.04 multiplied by 0.05. Close the bracket. If you have done that, obtain your answer first. That will give you, if you have done it correctly, you are going to get 335.2279463. If you have done that aspect correctly, you are going to have 335.2279679. Confirm. Great. If you have gotten that figure, now you have gotten the first part here. Now multiply by 0.2328. Multiply by 0.2328. That should give you 78 points. That should give you 78.04106.589. Great. You have gotten this first part. Now minus. Introduce minus. Then open a bracket. 360 multiplied by 0.2057. Close your bracket and obtain final answer. You should have 3 points. 3.98906.589. 0892. Your put value, don't forget it's in kobo. That put value will give you the put value will give you 3.98907 approximately. Remember, this is kobo. Confirm, thank you. This is just for one put. If I want to take it to Naira, I will just divide by 100. Is that not? That means my put value, if I'm taking it to Naira, Naira will give me 0.0398907. Because I want to get my answer in Naira. Now you have gotten put value for one put. Now, how many shares do we have in this company? I want to get total put value. How many shares we have in this company? I can come here. Let's go check. Although I know number of shares. Number of shares in this company is 5,550,000 shares. Let's go and check to reconfirm it. Look at the number of ordinary shares. 5,550,000 shares. I will now come here. Total put value. Total put price. Because we also call it value. Total put value, total put price, total put premium. Total put price should be number of shares 5,550,000 multiplied by 0.0398907. Please work this out. That will give you the value in Naira. What's your answer, please? I have 221,393. Two, 393. Please, can we confirm that? Please, can we try to reconfirm that? That's correct. Now, This is the price you should have paid. This is the fair price. This is the fair price. This is the fair price. If you are supposed to make payment, you should have paid 221,393. This is the fair price. Merchant bank is asking you to pay. So the investment bank, the is investment bank asking price. The asking price is 250,000. The investment bank say come and pay 250,000, but the price is 221,000. Is the price merchant bank charging you? Is it a fair price? Is the price merchant bank charging you to come and pay for this put option? Is it a fair price? That was the question examiner says you answer. No, thank you. The appropriate response is no. The price the merchant bank is charging is not a fair price. Let me save this. Option working 3. In case you are checking and you are looking at it, now let's just share the let's go back to the material. Look at the comments. It's just rounding off effects. Look at the comments. Holding other thing constant, the asking price of 250 is above the book value of the put option. Hence, the asking price is unfair. The investment bank is charging 28,555 above the theoretical fair value. That price the merchant bank is charging is not a fair price. The price the merchant bank is charging us is not a fair price. And that is the end of that question. Any question, please? Any question on A, please? Discuss what factors Grand Square should consider before deciding whether to purchase the options. What are the other things you should consider? All right, for the part A, any question? All right, other relevant factors to be considered. One is theoretical value is based on Black-Scholes option pricing model, which has a number of limitations. Theoretical value is based on Black-Scholes option pricing model, which has a number of limitations. You are trying to explain other factors into consider, including the assumptions. One, no dividend is paid in the period of the options. We are now looking at limitation of Black-Scholes model, that we have used Black-Scholes to calculate theoretical price. That model is based on certain assumptions that are not realistic. One is no dividend is paid. in the period of the option. That's an assumption. The company can decide to pay you dividends. Number two, Black-Scholes model applies to European companies. It can only be used for European options. We explained it at our last class. European options can only be exercised at maturity. It assumes that the risk-free rate is known and constant. In reality, interest rate is not constant. Interest rate can change. It's like saying that interest rate will not change for the next 6 months. Would that be possible? Again, the model assumes a constant volatility. Risk is not constant. Risk can change. Then number two, there may be transaction cost. The model assumes a perfect market where there is no transaction cost, where there is no taxation. In reality, if you are buying and selling shares, there's going to be transaction cost. Then number three, the company should consider protecting all its portfolio. Investments in Niger Dockyard. What that point is saying is that the company total portfolio is 100. Niger Dockyard investment is just 15%. So why are you protecting only 15%? The option is only available for 6 months. The company should consider whether to protect the investment after this period. So you can look at it. Any question, please? Any question, please? Can we take one more question within 45 minutes? One more question within 45 minutes. Let us try. Yes, it can be stressful. Not even for me that I still have lecture tomorrow morning. Let us look at question number 2. Briefly discuss the meaning and importance of the terms delta, theta, and vega in option theory. Please, let's read this. What is delta? Delta measures the sensitivity of option value to change in underlying asset price. What is theta? Theta measures change in underlying asset price. Theta measures change in option price as a result of change in time to maturity. What is vega? Meaning of vega. Vega measures the sensitivity of option price to a change of the assets. Please, let us try to read the notes. Like I keep on emphasizing to students, the SFM you are writing currently is a combination of theories and calculation. I've seen a student, he confirmed to me that he didn't do any calculation and he scored 63%. The student was just picking out all the theoretical question and writing. The bottom line is that the guy has qualified. Every other thing is story. All right. The B part of this question. Assume that your company has invested in 100,000 shares of Union PSC, a manufacturer of light bulb, You are concerned about the recent volatility in Union share price due to the unpredictable weather in the United Kingdom. You wish investment from possible fall in share price until 3 months' time, until winter in 3 months' time, but do not wish to share the shares. No dividends are due to be paid by Union during the next 3 months. Market data. Union current share price 200 kobo. Call option exercise price. That means this question is taking us to call. It's either you are dealing with call option or put option. Call option exercise price, that is the right to buy. The exercise price is 220. Time to expiry 3 months. Interest rate 6% annual. Volatility of Union shares 50%. Look at it. Examiner says in bracket standard deviation. Assume that option contracts are for purchase or sales of units of 1,000 shares. Devise a data hedge that is expected to protect the investments against change in share price until winter. Data may be estimated using MD1. Examiner has given us a clue. The data is MD1. Because I'm dealing with call option, the data is MD1. The first thing you are going to do, here we are not told to calculate premium or price. We are asked to data hedge. That means we want to protect our investments against fluctuation. Now let me explain briefly. What the examiner is asking you is that, how many call options are we going to buy or sell? If you have to protect our investments against fluctuation, our investment, we have 100,000 shares in a company called Union PSC. The current share price is 200 kobo. We now want to protect that investment against fluctuation in value. What the examiner wants you to calculate is, how many call options are we going to buy or sell in order to protect our investments in Union PSC against fluctuation in value? We now come and ask ourselves, okay, what am I going to use? Call options. That means I require D1. Normal distribution log of D1. For me to calculate normal distribution log, I must get my 5 input variables. We can move to the working board quickly. Let me expand this also small. to accommodate more workings. Okay, this is fine. I'll come here. First, itemize the 5 input variables. XO, what is the current stock price? 200 kobo. The exercise price, 220 kobo. Time to maturity, 3 months. Because it's not up to 1 year, you have to prorate now. That becomes 3/12. That will give you 0.25. Then your small letter R, risk-free rate is given as 6%. This is equal to 0.06. Then your volatility, examiner's standard deviation is 50%. This is equal to 0.5. Now get your D1. Put your formula out. Put your formula out in bracket XO E, close your brackets, plus bracket small letter R, plus 0.5 volatility square, close your bracket, multiply by T, all over 0 volatility square root of T. You have itemized your variables. Move on. Now go to your D1. My D1 is equal to in bracket my XO 200, my E 220, close my bracket, plus open another bracket, my small r 0.06 plus 0.5 multiply 0.5 is constant with the formula. Multiply by volatility is 50%. 0.5 square, close your brackets. Multiply by the T. 0.5. Then everything all over 0.5 multiply by root of time 0.25. We can pick our calculator. Let us go through it again, or let us try it ourselves. What? Let us try it ourselves. Let's go to it. In, open your bracket, 200 minus divided by 220, close your bracket, plus open another bracket, 0.06 plus 0.5 multiply by 0.5 square, close your bracket, multiply by 0.25. Obtain your answer. That will give you negative Let me write it out. That will give you negative 0.0490601798. Please confirm you have that figure. That is the numerator. Please confirm you have that figure. Once you are getting that figure, then now say divided by the two figure down, introduce brackets. 0.5 multiplied by root of 0.25. You should have your D1. Your D1 will give you, negative 0.1962. Please confirm you have gotten your D1. We are waiting for confirmation from the students.
Sir, you confirm you typed minus 9.9, but I got minus 0.049.
Okay, that's an error on my part.
Okay, so it's confirmed, sir.
Okay, it's an error on my part. Okay. Thank you for that. So, but have you gotten the final answer?
Yes, sir.
All right, great. You have gotten your D1. And please note, if you are talking of data edging, you don't require D2. If you are talking of this question is about edging, you don't require D2 for edging. So don't bother. Now move to your ND1. I can slightly close this out. Let me go up small. I can put a demarcation here. I will now go to our next working. Determine ND1 using normal distribution. Remember, pick your D1. Your D1 gave us negative negative 0.19 0.1962. You must establish a range. This figure lies between 0.19, 0.20. Now move to your ND1. The sign here is negative. Can you see? Then I'm going to start with 0.5 minus. Now open a bracket. Go check the log. 0.1 under 9. Let us check our normal distribution log. 0.1 under 9. Look at 0.1. I will now move to under 9. That will be the last. That will give me 0.0753. That will give me 0.0753. I've checked 0.1 under 9 plus 0.62. Open another bracket. Now go check 0.2 under 0. Look at it. 0.2 under 0. That will give me 0.0793. 0.0793 minus the lower, minus 0.0753. Please work this out. What's your ND1? Please work that out. Your ND1 will give you, look at it here, 0.4222. You can reconfirm. I've only taken that to save time. That will give me 0.42. I've gotten ND1. And that is the data of the call option. Confirm. You have gotten data of call. You can now go and devise a data edge. For you to devise a data edge, we explained it. We said data can be used as an edging tool. A data neutral portfolio is one whose value will not change as a result of change in the price of the underlying assets. The objective of a data neutral portfolio is to combine a position in assets with a position in option. Look at it. I will combine position in assets with a position in option. Now, to do that, enough of grammar. Let us demonstrate it in calculation. Look at it, please. You open a portfolio. A portfolio. You have quantity. You have data. Then you have total data. You start with assets. Your asset is the stock. How many shares does this company have as investment? 100,000 shares. I can refer you to that place. Look at this. Assume that your company has invested in 100,000 shares of Union PSC. That means our company will have 100,000 shares. Quantity of stock, 100,000. Remember, I want to combine assets and option. Now, what is the delta of an asset? I've mentioned it severally. Delta of an asset is 1. It's always constant. The delta of an asset is 1. That's okay. 100,000 multiplied by 1. Total delta here is 100,000. They are now bringing call option. What is the number of call option required to hedge? I don't know. Yes. Denote it with letter X. That is what we are trying to calculate. Then what is the delta of a call option? Delta of a call option is ND1. Your ND1 as computed is 0.4222. Therefore, total call delta X multiplied by 0.4222. That will give me 0.4222x. To achieve neutral position, total delta must equal to 0. For me to talk of to achieve a neutral position, to avoid fluctuation, the total delta, that is the addition of asset delta plus option delta, must give us 0. If you are to achieve what we call neutral position, if total delta is 0, then what is X? You can now come here and say, look at it, form an equation. 100,000 plus 0.4222x is equal to 0. I can make this subject 0.4222x is equal to negative 100,000. I can manage here. Let me use red biro. I want to manage here. Please note. My X is equal to negative 100,000 divided by 0.4222. What is X, please? 100,000 negative divided by 0.4222. That will give you negative, our X is equal to negative 236,855 approximately. That is number of call needed, negative 236,855. Thank you. And the question says that 1,000 shares is equal to, assume that option contracts are for purchase or sales of unit of 1,000 shares. One option is for 1,000. So how many options am I going to buy? I've gotten, I'll just come here, divide this by 1,000. Please let me save this so that I can take a new one and we can round up properly. Let's save this. We can round up properly. Working 3. Okay, maybe working 4. Now let's move to a new one that we can have it clearly stated. You have gotten your X to be negative 236,855. Then I say, assume that option contract is for purchase or sales of 1,000 of sales of unit of 1,000 shares. That means one option is for 1,000. One option is for 1,000 shares. I can now say, okay, option to be purchased. Just divide it by 1,000. Call option is equal to negative 236,855. That will give me 236.855. What it means is that if I purchase one option, is equal to 1,000 shares. So since one option is equal to 1,000 shares, I can also say, okay, I'm going to purchase approximately to the nearest whole number, negative 237. Call options. Now, the negative sign has a meaning. If you have a negative sign, because you must comment. Examiner says, are we going to purchase or sell? If you want to comment, once there is a negative sign, it indicates sell. That your comment now become the company should sell 237 call option so as to hedge against fluctuation in investments value. Once you have a negative sign, if you are delta hedging, you now get your negative sign. It indicates selling. But if you have gotten a positive sign when you are delta hedging, it implies buying. We are done with that question. And it's a good way to actually round up that question. It's a good way. We are done with the question. Comment upon whether such edge is likely to be successful. We can do that. That one is fine. We are done with the question. Look at the solution here. Because the figure is negative, we need to sell 236,000 855 call option, or if you divide by 1,000, 237 call option contracts, because that sign is a negative sign. Then the last aspect, examiner says comment if the hedging you have, if the above hedging is likely to be successful. A hedge such as this is only valid for a small change in the underlying share price. That hedge will only be valid if there is a small change in share price. As the share price changes, the option data will change, will alter, and the hedge will need to be periodically rebalanced. What we are saying is that hedge is not likely to be successful unless there is a small change in price. If there's, as the share price changes, option data will also change. And that hedge, once option data changes, that hedge will not be valid. The hedge will need to be, the hedging will need to be periodically rebalanced. Please, let's try. Never can tell. A lot of times, now we ask questions on options. Then we just abandon it. Abandoning it is because they don't have knowledge about it. All right, any question, please? You can look at question 3 to improve your knowledge. You can look at it. Oh, you can look at it for this weekend. Any question, please? All right. If there is no question, we call it a good night. I believe very soon we are going to wind up the class. I think I have just like one topic to treat with you again after hedging, after option. All right, let's have a blessed evening. May God give us a better understanding. Let's remain blessed. Good night.